Welcome back. So now we're going to solve some problems. All right, so a cube of metal has a mass of 1,350 grams and displaces 540 milliliters of water when immersed. So let's look at our measurements here. What is this displaces 540 milliliters of water? What does that give us?
Is that the volume?
That's volume. All right, so in your notes, I think you have this problem, right? Oh. Man, doesn't want to write now. Come on. It's even worse now, my orientation. So, displaced liquid or water equals volume, right? It's irregular objects, it's hard to find the volume of. If a rock's not a sphere or cylinder or prism shaped, it'll be difficult to find the volume. So one way we can find the volume is by the amount of water or liquid it displaces. So anytime we see a kind of displaced liquid or water, that's going to give us volume. All right, so add that to your notes. So now our density is going to be the mass of our metal. So the mass is 1,350 grams. The volume is the 540 milliliters of water it displaces. So our density is going to be 1,350 divided by 540. A lot of times we will change this from a fraction to a decimal because sometimes we're comparing the density of two different objects, and if they're fractions with different denominators, it's going to be hard to compare them. So we'll change these ones to a decimal. Right? What did you get as a decimal?
5.
Is it 2.5 exactly?
Yeah.
Okay. So 2.5, and then we need our units. What would our units be here? Grams per milliliter is correct.
Yeah. Yes.
If we wanted to, we could change them to kilograms per liter, but really there's no reason to. There's nothing wrong with grams and milliliters.
So we could either change it or we could leave it.
Yeah, because they'd each be 1,000 more. So, but that's I wouldn't bother changing. I would just keep the units that it has.
What does the G stand for?
G stands for grams.
Okay. Thank you, Ivana.
You're welcome.
All right, so let's solve another problem. Everyone good? You need the notes up? Okay. Let's solve another problem. Leave it up? Okay.
Bruh. Say, copy off Amber. God damn.
What did you just say?
Copy off Amber.
Amber doesn't have a room. Down. Okay.
You sure?
Go. Board.
Excuse me?
All right, so here we have next question, and that 3 there was supposed to be a exponent. It's supposed to be cubic, centimeters cubed. So when it follows a number, a measurement like that, just assume that I meant to have it be cubed, but it's kind of not. All right, so we want to find number 2 here, which is, or number 1 in your notes here, which is we have 260 grams of salt, has a volume of 100 centimeters cubed. What is the density of the salt? All right, so we have our mass. Our mass is 216 grams. The volume, 100 centimeters cubed. All right, so now we can find our answer here. So we'd have 216 grams divided by 100 centimeters cubed. And what would that give us?
2.16.
2.16 grams per centimeter cubed. Now we could, what's that? Yeah. Now we could switch that. Remember we had over here, we went through the units, and our centimeter cubed is the same as a milliliter. So we also could write this as 2.16 grams per milliliter. Right? Either of those would be correct.
Is it cubed or is it?
Not the milliliter, no.
No, centimeters.
But the, what's that?
Centimeters is cubed.
Centimeters is cubed, yes.
Wait, so essentially centimeters and milliliters are the exact same.
Yes, the cubic centimeters and a milliliter are the same. So a ball,
Cubic?
what's that?
It has to be cubic centimeters?
Yes.
Okay.
Yeah. A ball has a mass of 46.9 grams and a volume of 40.5 centimeters cubed. Right? So we have our mass. So when we're given the mass and the volume, density is pretty easy to find. Sometimes we're going to have to do a little bit more work, though, to get our density. But let's do our probably our last easy one here. Volume was 40.5 centimeters cubed. Right? So that's going to give us 46.9 divided by 40.5. Right? What would that be as a decimal?
1.16.
So
I broke it down. I was very sorry about.
let's take the 1.158.
Yeah.
More decimals is generally better because we'll have a greater accuracy. So 1.158 grams per centimeters cubed, or, and I don't know why my decimal is so far away from the number there, 1.158, or 1.158 grams per milliliter.
So you would want us to go to 4 decimals?
Yeah, you could, I would include at least 4 decimals. You can include more. I think we have time for one more problem. Anyone need this up? The notes up? Okay. Good? All right, so let's take a look at this one. All right, so gold has a density of 19.32 grams per cubic centimeter. We want to rewrite the density equation for each of the following. All right, so, and I want you to put all that I have written up in on the board already in your notes. There's room on that page. And then we're also going to rewrite our density equations as well so that we know, what if we don't want to find density? What if we want to find mass or volume? How do we do that? All right, so our equation was density equals mass times volume. And actually, I'm going to write it down here. I don't have enough space over there. And then we'll put it up there. All right, so we have density equals mass divided by volume. All right, and so we want to solve for mass. All right, so I have the steps written in your notes. You can add that to this. So we're going to multiply both sides here by volume because we're trying to isolate our, squeeze that in there, our mass. All right, so if we multiply both sides by volume, this would cancel. And so now we have volume times density is equal to the mass. All right, so mass is equal to volume times density. And I think we'll stop at that point, and then tomorrow we'll look, tomorrow we'll look at solving for volume. Thanks for watching the podcast.